is 10 inches, BC is 15, and here is 10. So here from here is equal to 10 inches. So we take the moment equal to 0, so that means M should be equal to 3,000 pounds multiplied with 10 inch. So that is 30,000 pound inch, right? Am I okay? And the direction is as indicated like this. The direction is important. Okay, so far it is static. So far everything is static. So right now you can see the feature is this. The result, reaction force equal to 0 and bending equal to 30,000. The reactions on the cross section really doesn't matter by x as long as we confine the NN within the BC. As long as the cross section is picked within the BC, the result will always hold.
Your moment will be going this way, right?
Yeah, this one, the two pairs, these pairs of the force will produce the bending in this way.
Well, I'm just saying, because you have your arrow for the moment.
Say that again?
Because your arrow right there for the moment, you have it going counterclockwise.
Yeah, you can tell, okay, first one, this pair will produce a moment in this way, right?
Well, that's what I'm saying, is like your arrow over here.
And
right
arrow here,
right
this one.
Yeah, you have it going the other way.
Yeah, and then this is the moment exists here to counterbalance this one.
Oh, okay.
Okay?
You're taking your moment from the right or the left side of the beam?
We take the moment on the right side of the beam, yes. Okay? So in this way. And again, the values will be constant, doesn't matter as long as the section is in BC. So now we can translate information. So that means here.
Wouldn't your moment have to be taken around the left side of the beam? Otherwise.
Yes, I'm going to do it right now. So now for this beam, so this is A, B, C, and D. So for example, this is our cross section. So from our free body diagrams, if we take the cross section, the bending is like this, 30,000, right? And now if I take the cross section, the free body diagrams of the second part here. So this is action reaction. So here on this side, the bending equal to 30,000. Okay? So that is the questions. Depends on which side you're talking about. And the bending, for example, we pick out on this side, that should be like this. So now if we only take the free body diagrams on the BC's portions only, so that means here, sorry for people sitting in the back, I need to use the bottom space here. So this is C here. So here is moment, here is 30,000. Okay? Okay, so now for this case, basically in BC portions, and what we have actually is this province. It is under the constant bending equal to 30,000. And M equal to 30,000. And this value won't change, doesn't matter which section you pick. And now you can see this is come to our pure bending, our generic models. Okay. So now starting from here, already we identify so here we keep this generic model here, then we can begin to work on. So now in this model, we have already identified the M, the value is 30,000 pounds inch, and by sign convention it's positive, okay? So now we're going to determine I first, okay? And I is the moment of inertia with respect to the neutral axis. So the neutral axis, we look on this one here. So Okay, let me erase this part. And now we're going to calculate I. Huh?
I'm just confused on your moments. Like, are those reactive moments? Like,
Reactive.
Because, I mean, if you take the moment, it's going to be going the other. That's why is that like a reactive reaction?
Reaction exists is to counterbalance to get everything equal to 0.
So that's what you're doing.
For example,
like
if this is an object, if the object by its external loading, we have such moment, it must produce counterbalance to get in 0.
No, I understand that. But
Okay.
like from the forces you have up there,
Yes.
how does that create a positive moment when you're pushing down like that?
The red one was the reaction moment.
So these are force. So this pair will produce this one.
Yes.
You have
Okay.
a couple moments that
We talk about this one privately in after class. Okay, we proceed. Okay. And now we back to the moment of inertia here. Here again I is the moment of the inertia about the neutral axis. And what is the neutral axis? Neutral axis is that is to passes the centroid of the cross section. So here we have to determine by all means is first where is the location of the centroid. And centroid, basically, you should have a common sense. Centroid should go, for this case, it must be located higher, not from the center, okay? It should be higher from the bottom because the bottom is thinner, okay? And so from here, we have to determine this one. As long as we determine this case, because for this case, this is a beam protruded in this way, and now this beam is bending. If you look at from the outer board, the bending is like this, right? Can you see? Okay, the beam is protruded and bent over like this. So that means here is our orientation. This should be our neutral surface, neutral axis. Okay. Any questions? And now as long as we can determine this position, we're done. And how to calculate the centroid. And here again, that is the statics. And here, say for example, let me label certain positions. For example, here, let me say pick up the measurement is from the top to here is let me call this the Y bar. And you can take any reference to measure the locations. And once, for example, you can also take the bottom as your datum to measure this one. So as long as you pick a reference, you just keep consistent in calculations. Okay, so here, follow up my lecture notes. I pick the bottom and the top one. So here, the calculation is this. To find the locations of the centroid is this. So here we decompose the cross sections into the simple composition of the simple geometry. For example, I decompose into the upper portion. Let me call this a 1 and this is 2. 2 areas, and this is location we're looking for. Okay. We're looking for Y bar. And the Y bar, this position, if you remember from your statics, basically that is tell is once you have the couple simple cross section, basically that is AI, YI equal to the total area times Y bar. we simply take up this formula. And what I mean, for example, here we can say if this is the area 1, this is area 2. And AI, for this one, again, let me impose the dimension. This is, so the area of the first, of area 1, this is equal to 2. Okay, and say if this is inch square. And yi, that is to indicate, for example, for the first sections, it has the centroid at its center here. And that represents the yi, that means here is the distance y1. Okay, that means that represents is the distance of the centroid from to the reference we take. Here we take the upper portion, the upper line as our reference measurement. So here this is should be 0.25. And the unit is in inch. Okay, now we work on the second one. The second one here we have the geometry here from here to here. This is 3. And here is 0.5. So the area equal to 1.5. Okay. And now here is the centroid of the second this is a centroid of the second portion here. So we know that this one from here to here is how much? It's 1.5, right? And from here to here is 0.5. So y2 bar, the y2 should be equal to how much? 2. Are we okay? Okay.
So our origin is at the top of the top bar then?
Yes, because here we pick this is our reference, our data, D-A-T-U-N. Okay. So now we simply take it up, and for example, here we want to calculate is AI, YI. So here the AI, YI is 0.5.
Can you explain why for the second one is 2 again?
Yes. This is the Y2 we're looking for. Let me do this one to here. This is Y2 we're looking for. Okay. And now this multiplied together is 3. So therefore, here the summation of the AIYI here is 3.5 and equal to the total area. This is summation here. The total area is 3.5. This is 3.5 and equal to 3.5 times y bar. Are we okay? So therefore, y equal to 1. So here we determine this location actually is 1 inch below the top edge. Okay. So now we have determined the location of the neutral axis. So here we have location of the neutral axis. So we've done this one. So now the next one I'm going to calculate is the value of y. As I want to do last time, you take the more than 80-90% of your calculation just on the value of I. Okay. So if no question, then I'm going to erase this space for I. So now I'm going to calculate I. And again, the I is the properties of the geometry. So that means we will be able to, now is to calculate I. So this is our geometry and cross sections. And again, we can decompose into two simple sections. And I need to give you a few formulas to for example, if we consider rectangles, and here is, for example, here is called the, how about that, B, and the height is H. For this case, the I respect to the x-axis, which means this axis, is equal to 112 BH cubed. That is the formula provided by this. So always here is the cube. This cube go to the turn, that is the dimension being bisected by this axis. Okay? So that means IY will be equal to 112 and dimensions HB cubed. The B is the dimension being bisected by y-axis, about which we're going to calculate. So cube term go to that dimensions. And for example, if we want to calculate the moment of inertia with respect to other axes, for example, here I provide another axis. Let me call capital X, capital Y. Then we can calculate I respect to the x-axis. So this one, we have the formula we call the parallel axis theorem. That is saying is this. That is equal to I respect to the axis passing through the centroid plus the total area multiplied with the distance, for example, from here to here, is, let me call the, what number you like? Huh? Which number you like? No. Which parameters you like?
Delta little y?
How about we say D? dy, okay? And I respect to the y-axis. And that is IY plus area, the distance from here to here. Let me call it dx. So dx squared. Okay, those are the formulas. And you can use these formulas a lot. And actually this one is we call the parallel axis theory. Okay, so we have the equation kind of review there, so we can pick the information. So now the I of the whole things will be equal to I1 plus I2. And I1, I2, that means, again, remember, is about the neutral axis. Okay, so here, I1 respect to the neutral axis. Where is I1? So this is a cross-sectional portion of the 1. And this is the neutral axis. So from here you can see for this first segment here, this is the centroid of the first one, but we're going to calculate is about this axis. So right now you can see for this one, we have to pick up is this formula, right? Can say it? Okay, so now if we can say it, and then we can simply try. So here, this one basically is the I1.